Guys, good morning everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S Exam Prep. Yes, very good morning everyone. Welcome all to the session. Welcome to the Linear Algebra class. Yes. So, as asked by students, as demanded by students, this important topic of linear algebra, I am going to cover you in this particular weekend with the help of the concepts through questions. Yes, the 51 most expected questions of linear algebra, and today is the part number 1, and this part number 1 we are first of all going to discuss up the questions and the concepts based on rank and linear system of equations. Rank and linear system of equations. Come on everybody, quickly join the session. Very good morning Prashant, Ravi, Anitha, AKJ, and sorry for a delay. The session was supposed to be scheduled at 11 a.m. but due to some electricity power cut, we had to reschedule it. Right, I had to travel to other place to take it, so that is why we got we have rescheduled to 11:30. Yesterday I informed you about 11 a.m. but it has started 11:30 due to, again I repeat, due to power issues. Right, but yeah, whether it starts at 11:30 doesn't matter. Do we have the same energy? And of course we are going to cover the similar content as I planned for 11 a.m. also. There is no difference in the content. Good morning Akbar, Sagnika, Satish. Very good morning. Let everybody join quickly. Right, so since the session was rescheduled, everybody quickly update your friends, okay, to join using the new link. This is a new link created. To share this link upon everybody, because this is the newly created link. Everybody share the link of this particular session to all your friends. Good morning Shiva. Okay, so that all others who were in plan to join, they could also join this session. Just a second. Okay, chalo, cool. Let's get moving ahead then. Let's get started. Okay guys, so this is a brief intro in case somebody new to my session. This is your mentor and educator Rakesh, and I have secured all India rank 9th in the GATE examination, completed my masters from Indian Institute of Science, Bangalore, and these are my major area of expertise. Right, in the technical I deal with control signals, digital and EMT, and in the general I deal with the maths and aptitude, and this is the engineering maths session. Right, this is the engineering maths session. You can also connect me through the Telegram. I'll share you directly the link of the Telegram. Okay, I'll directly share you the link of the Telegram. Very good morning TRB, Akshata. Okay, so guys, one more session for you I'm bringing, and I just want to give you a small update about that particular session, and that is coming on this Sunday night 8 p.m. This Sunday night at 8 p.m. Last 3.5 months are left for the GATE examination. Clear any of your queries if you have, and what are the main queries that the students will have at the last moment. What are the frequently asked questions by the students? I'm going to come and answer for all of you. That is, now in the remaining time, what should be the number of hours? From where you should practice intensively now, right? What is the right time to start test series, especially the mock test? What is your revision plan? What is your revision plan? And is 75 plus possible now? Is 75 plus possible now? Okay, we are going to come live tomorrow Sunday at 8 p.m. with this session. It's going to be a small session to give you a general idea about the last 3.5 months left for the GATE examination. And guys, this is the question number 1. We will keep maintaining the sequence as well, so that you will know by tomorrow. Tomorrow also you have the class at 11 a.m. for the linear algebra part number 2, and you should know that we are going to cover all 51, as I promised. 51 means 51 questions we are going to cover, isn't it guys? Chalo, good morning all, keep joining. And guys, come on, right, first question, answer this, and do not forget to like the session. I see very less number of likes right now. Maybe the session was newly created. Do not forget to like the session. Start with a positive motivation. Everybody show your love, show your response, and like and answer the question. What is the rank of the following matrix? What should be the rank of the following matrix? Now we'll start with all possible cases, and I'll tell you the Echelon method, determinant method, shortcut method, all possible methods I'm going to tell you. If you have a look into this matrix, what is this type of matrix? What is this type of matrix? It is clearly upper triangular, isn't it? All the elements below the diagonal are 0. Hence, it is an upper triangular matrix. Now, what is the determinant of upper triangular matrix? What is the determinant of any triangular matrix? It is the product of diagonal numbers. So that is 1 cross 4 cross minus 2, which is minus 8, eventually not equal to 0. So what is the determinant of this matrix? It's not equal to 0. Now, one of the way of understanding rank, I'll tell you several points about rank. We will discuss several things about the rank, right? But first thing you can notice, rank is the largest order of non-zero minor of the matrix. It is the largest order of non-zero minor of the matrix. So this is a 3 cross 3 matrix, right? This is a 3 cross 3 matrix, and how many minors you can make? Now, number one minor you can make is a 3 cross 3 minor itself, right? So if I want to talk about, let us understand in the first question. If I want to talk about a 3 cross 3 minor, so that is itself the matrix determinant. Let me copy the numbers. Right. And this itself is not equal to 0, as we have noticed. Okay. And that is why the rank of the matrix, which is the largest order of non-zero minor. So I have a 3 cross 3 minor. I have a 3 cross 3 minor, which is non-zero. So rank has to be 3. Rank has to be 3. Right. Suppose if this was 0. Okay. Suppose if this was 0. Suppose, imagine kar lijiye, if this was 0. Okay, this is not the final method. I'm just making you understand something. Suppose if this was 0, then you will go and check some second order matrix, 2 cross 2 minors. So these are 2 cross 2 minors. Okay, you can make 9 2 cross 2 minors, etc. These are known as 2 cross 2 minors, but here you don't need to check. Any 2 cross 2 determinant which you can extract from the matrix is the 2 cross 2 minor. Right. So if suppose this was 0, then we will check whether the 2 cross 2 minor is non-zero, and if the 2 cross 2 minor is non-zero, then the rank would be 2. Something of this sort, okay? But here the 3 cross 3 minor itself is non-zero, and as per the first key point I'm mentioning, rank is the largest order of non-zero minor of the matrix. So which is the largest order of non-zero minor? This is non-zero. Acha, this is also non-zero. This is also non-zero, but this is not the largest order. The largest order is 3, and hence rank is known as the 3. That simply means if there is a square matrix, if there is a square matrix like 3 cross 3, what can be the maximum possible rank? The maximum possible rank can be 3. Here it is 3 only, right? In general, if there is a square matrix of size n cross n, if there is a square matrix of size n cross n, then the rank is always less than equal to n. Or I can say that the maximum value of the rank is equal to n. The maximum value of the rank is equal to n. Rank will be n or less than n. Okay? No. Largest order of non-zero, Shiva. Right? No, rank will not be 2. Rank is the largest order of non-zero minor. See, this is non-zero, so my rank is 3. You don't need to actually check this. Okay, I've just written to show you 2 cross 2 minor. Suppose if this was 0, then you go and check. And if this is non-zero, then the answer will be 2. Okay, Shiva, understand the difference. Largest order. Okay. Similarly, if there is a non-square matrix of the size m cross n, then the rank will be less than equal to minimum of m comma, and depending on whether m is len or n is len. Say for example, I take a 2 cross 3 matrix. Suppose this is a 2 cross 3 matrix. I make a non-square matrix all there. Okay. If this is a 2 cross 3 matrix, then what is the rank? I'm not asking the final value of rank, but what can be the maximum possible rank? So what is the maximum possible minor? Can you make a 3 cross 3 minor? For a 3 cross 3 minor, you need 3 rows and 3 columns, right? Can you make a 3 cross 3 minor? No. Maximum you can take a 2 cross 2 minor. Maximum what you can take is a 2 cross 2 minor. So what is the maximum possible rank of this matrix? What is the maximum possible rank of this matrix is equal to 2, minimum of mn. I'm not telling rank is 2. I'm not calculating. I'm not bothering. I'm just telling you some important points. Baad mein calculate karenge, right? But what I'm trying to say you, कि whenever there is a non-square matrix, the rank is always less than equal to minimum of mn. Minimum of mn. Now, previous case, it is a 3 cross 3 matrix. A is a 3 cross 3 matrix. So what is the maximum possible rank of a 3 cross 3 matrix? As I told you, rank is less than equal to 3. Maximum possible rank is 3, but actual rank is also 3. In the previous question, actual rank is also 3. Actual rank is also 3. So whenever a matrix attains the maximum possible value, whenever the rank of a matrix attains the maximum possible value, then it is said to have full rank. So this is the condition of full rank. Whenever a matrix attains its maximum possible rank value, then it is said to have full rank. So this is the full rank condition. Okay. So as I told you that with questions, I'm going to revise the concepts and the points also. Just stay tuned and stay updated, and I don't see that likes increasing, guys. Dull morning, bright morning, motivated morning. What is that, guys? What is that? Okay, we see little very slow and sluggish type of response. Okay, right. So if a square matrix is non-singular, ab dekho. Non-singular matrix is what? Non-singular matrix is one which has non-zero determinant. A singular matrix is one which has zero determinant. So here the matrix has non-zero determinant. So I will call this matrix as non-singular. Okay. I will call this particular matrix as non-singular. Is it okay? I'll call this matrix as non-singular. Ye dhyan rakhna. Okay. Now if this is a non-singular matrix, that is why the rank was equal to full, na? Okay, determinant non-zero, rank is equal to 3. So whenever a matrix is non-singular, then it will have full rank. Okay, this is a very important point, last wala, but leave it for a moment. I will discuss it after a few more minutes. Okay, so whenever a matrix is non-singular, that is having non-zero determinant, it will always have the full rank. ठीक है, ये condition याद रखना है आपको. Now, let us understand what echelon form is. In some of the questions, echelon method will be applied, and then I will come to the independency wala. This is the best, this is the shortcut. You can solve most of the questions within seconds because of the last property. So I'll come back to that, but first let us understand what echelon form is, right? Specifically talking about row echelon form. Right? A matrix is said to be in row echelon form if zero rows, if there is any zero rows, they must be below the non-zero rows. So number 1 point, in simple I will write down. In short, I will write down row of 0. I will call the row of 0 as ROZ. Row of 0, right? If any, must be at last. If any. अगर नहीं है तो कोई बात नहीं. Number 2 condition. The number of zeros before the first non-zero element in every row. I will call it as number of starting zeros, and I will explain you through the question. Number of starting zeros must be in increasing order. Must be in increasing order. Let us understand very simply. इसको एकदम simple तरीके से understand कर सकते. Have a look into this. 1 2 0 0 4 5 0 0 minus 2. 0 0 minus 2. ठीक है? चलो. Now same question, guys. It is the same question. The same question which we have solved by the determinant. Now I am going to explain you the echelon form. Is there any row of 0? Right now I am not able to see any row of 0. Let us count the number of starting zeros. I told you, na? What is the second point? Number of starting zeros. Okay, so understand here, let m is equal to number of starting zeros. Let us say m is equal to the number of starting zeros. So guys, what is the value of m here? Starting zeros. Starting zeros means whatever the zeros you see in the beginning of any row, that is m is equal to 0. This is known as m is equal to 1, and this is known as m is equal to 2. 0, then 1 0, and then 2 zeros. This is the starting zero. These are the starting zeros, right? Is it following increasing order? Yes, it is increasing. So number of starting zeros are increasing. There is no row of 0. If there was a row of 0, it must be at the last, but there is no row of 0. That means it is in the echelon form. It is known as the echelon form. So this matrix is in row echelon form automatically. I will tell you some questions where the matrix is not in the echelon form. We will convert into echelon form. We are going to convert into echelon form, don't worry. But this is already in the row echelon form. And then I told you, whenever a matrix is in the row echelon form, then dear, the rank is equal to number of non-zero rows. The rank is equal to number of non-zero rows. So what should be the rank here? How many rows? This is non-zero, this is non-zero, this is non-zero. All the 3 rows are non-zero. Now, what do you mean by 0 row? All elements must be 0. All elements must be 0. Right? So, rank of A is equal to number of non-zero rows, that is equal to 3. Already we have commented that the rank is going to be 3. Already it was specified that the rank is going to be 3. Here also we have found that the rank is going to be 3. So R of A is equal to the 3. Right, dear? R of A is going to be 3. Chalo. Cool. R of A is equal to the 3. Chalo. Great. Moving ahead to the next then. Moving ahead to the next. Okay. Find the rank of the matrix. Now see. Find the rank of the matrix. Once again you see, I have taken this matrix separately. There is a row of 0 here, but that is at the last. Okay. Let us count the M. M is what? M is number of starting 0. That I will fixed. Okay. That is fixed. Let's say M is the number of starting 0. So what is the M here? M is equal to 1. What is the M here? 2. 1 0, 2 zeros and 3 zeros. What is the M here? 3. Acha, automatically you are able to see, yes, there is a row of 0, but that is at the last. If it is not at the last, you have to do some adjustment to come it into last. Okay, so row of 0 is at the last. Number of zeros are in the increasing order. Okay, so this clearly says that the matrix is in echelon form. Matrix is in echelon form. Matrix is in row echelon form. And if the matrix is in the row echelon form, what is going to be the rank? Rank is number of non-zero rows. Clearly, 1 is the row of 0. So how many non-zero rows? Sir, 2 non-zero rows, and the rank of the matrix is equal to 2. That is what is the meaning of echelon form. Next question, number 3. Have a look into this. Have a look into this matrix. 0, 5, 3, 0, 0, 2, 0, 0, 6. Okay. And I've copied this matrix once again here. Okay, 0, 5, 3, 0, 0, 2, 0, 0, 6. Acha. Ab dhyan rakhna. What is the value of M here? 1. Right. Then next row, what is the value of M? It is 2. Right now, there is no row of 0. Next row, number of zeros, starting zeros is 2. Number of starting zeros strictly, okay? Acha ji. Okay, now tell me, does it follow increasing trend? Does it follow the increasing trend? Does it follow the increasing trend? No, it should not be same also. Strictly increasing. Strictly increasing. It should not be same also, right? So this is same. So this is not the echelon form. I will now say that this is not the echelon form. So what to do, dear? What to do then? How to convert into the echelon form? Everybody with the big fire. Right. Right. Yes, yes, yes. The PDF you are going to receive for this session, password protected. Password I'll tell you after some time, I don't know. But yeah, PDF you will receive that to password protected. So stay tuned to the session, have a look into this. Okay, this is not the echelon form. So what to do, sir? Okay, what to do? So I will convert it into echelon form. So what I'm going to do, have a look into this, right? To convert into echelon form, this should be increasing, na? And for it to be increasing, 1, 2, 3. Yahan pe aana chahiye 3. 1, 2, 3. Yahan pe aa jana chahiye 3. Is it okay? Here, this should be the 3. Correct? Eh? This should be the 3. So, 3 zeros means I have to make it this 0. So, I have to apply the elementary row operations. I have to apply the elementary row operation. I have to convert this 6, which is in the third row, to 0. R3 can be written as R3 minus 3R2. Right? Multiplying this by 3, 3 2s are 6. 6 minus 6 will become 0. Right? So, doing this, performing this, I am going to get the matrix, which is 0, 5, 3, 0, 0, 2, 0, 0. 0 minus 0, 0 minus 0. 6 minus 3 into 2. That is again 0. That is again 0. Now have a track of M. M is 1. M is 2. M is 3. 1, 2, 3. M is 1. M is 2. M is 3. Right. This is what is the increasing order. This is what is known as the increasing order. All dear students, this is what is the increasing order. Okay. Now this is correct in the echelon form. Now this is correctly in the echelon form. And if this is in the echelon form, rank is equal to number of non-zero rows. There is clearly a row of 0. Row of 0 is at the last. Very good. I wanted at the last only. Number of non-zero rows 2. Hua. Answer for the rank is equal to 2. Answer for the rank is equal to 2. Okay. Next one. Find the rank of the matrix. Find the rank of the matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll tell you 2, 3 things here. I'll tell you 2, 3 things here. Dhyan dena. Now, with this, let us summarize all of the points. Very important. With this, let us summarize all of the points. Okay. With this, let us summarize all of the points. Number one, okay, number one, if I just calculate the determinant, right? Method number one, if you calculate the determinant of this matrix, this is going to be 0. I hope you can complete the calculation. Huh? Please try and complete the calculation. Okay. When you calculate the determinant of this matrix, that is going to be 0. That is going to be 0. Chalo, one single step, I'll do it up. 1, 5 9s are 45, minus 6 8s are 48. Minus 2, then you have 36 minus 42, and plus 3 times of 32 minus 35, right? So minus 3, then plus 12, and this is minus 3, minus 9, answer is 0. I told you it is going to come up as 0. Determinant wale method se dekhen. So we are summarizing all the things with this important and another trick to be introduced with this question. Okay, so just please concentrate, right, and keep liking the session. So ye ho gaya mod A equal to 0. So if determinant is 0, rank cannot be 3. Rank cannot be full. But it is a 3 cross 3 matrix, na? So what is the rank? It is less than equal to 3. The maximum possible rank is 3, but here it is not going to be 3. Here it is not going to be 3. So what is going to be the rank? I will check a 2 cross 2 minor. Utha lete hain isko. Let us take a 2 cross 2 minor. 1, 2, randomly, random. This is the random method. Then we will go to the Echelon method also. What is the value of this minor? 5, minus 8, minus 3, non-zero. Any one non-zero 2 cross 2 minor, rank will be 2. You don't have to check all minors. Even if you have one non-zero minor of order 2, rank will be 2. Good afternoon, Sayal. So rank is equal to 2. I conclude rank is equal to 2. Even if you have one non-zero minor of order 2, rank will be 2. Rank will be 2. Rank will be 2. Yes, Sagnika, coming to that. Indirectly, I'm going to come to that, okay? So rank is equal to 2. Bahut badhiya. Chalo, great. Rank is equal to 2. That is sorted all of us. That is sorted to all of us. Next. Now, next method. Okay, let us talk about the method number 2, the same Echelon method. Same Echelon method. Very clearly, number of zeros, 0, 0, 0. Number of starting zeros. M, number of starting 0, it is same. So this is not in the Echelon form. I will quickly apply the elementary transformation. Okay, then we will come to the shortcut. Story will be over by that shortcut. So dhyan dete chalna. Right, dhyan dete chalna. So what is going to be the result here? What is going to be the result here? I will apply the elementary transformation. R4 is equal to R4 minus 4R1. Right, पहले इसको 0 करेंगे. Right, and then इसको 0 करेंगे. Sorry, R4 क्यों लिखा मैंने? Sorry, that is R2. I'm so sorry for that. That was R2. Row number 2 is R2 minus 4R1. And similarly, 7 को 0 करना है, तो R3 has to be R3 minus 7R1. Let us follow this much. And after completing, after completing this much, the matrix है, the elementary operations, right? 4 minus 4, 0. 5 minus 2 into 8, minus 3. 6 minus, kitna 4 se kiya? So this is minus 6. Next, 7 times, 7 minus 7, 0. 8 minus 14, minus 6. 9 minus 21, minus 12. Okay. Now, very clearly, the second and third row are identical. Okay. Second and third row will be identical. Yeah, for some of the questions, Echelon will be lengthy. That is why I'm going to come up to the shortcut method. Hania, just wait. We are going to come to the shortcut. Yes, I also agree. For some of the questions like this, Echelon can be lengthy. That is why we need to reduce it. Determinant method is simple. This is the very random method, but you can apply. Finally, shortcut pe aata hu main. Okay. Now, what you're supposed to do here? Now, the next step that you can do is, okay, this is already 0. So, 0. Then one single 0. I want 2 zeros. I want the number of zeros in the increasing manner. Na? Increasing manner. So I have to make this as 0. So kya karenge? Multiply above number by 2. They become equal and then subtract. So what is the operation, dear? What is the operation, dear? R3 can be written as R3 minus 2R2. R3 minus 2R2. So that my matrix becomes 1 and 2 and 3. 0 and minus 3 and a minus 6. 0. And then 0, minus 12, and this is also becoming minus 12 after multiplied by 2. This is 0. Now have a count of the number of zeros. Sir, number of zeros nil, number of zeros 1, number of zeros 3. It directly becomes 3, but it is increasing now. I only want increasing. It is increasing. Yes, we all can agree that it is increasing. So this is already the Echelon form. There is a row of 0 also, that is at the last. Row of 0 at the last. So it is the echelon form, and whenever a matrix is in the echelon form, rank of the matrix is number of non-zero rows. These are the two non-zero rows, third one is 0. These are the two non-zero rows, third one is 0. Third one is equal to 0. Third one is 0. Rank is equal to 2. Same thing we got. Rank is equal to 2. Now let us talk about the shortcut. Let us talk about the shortcut. Method number 3. Let us talk about the shortcut now, guys. Dhyan dena. Please pay attention now. I understand that for some of the methods, for some of the questions, minor one was fast. Echelon is good for some of the matrix, but in general, this is lengthy. Okay, so what is the best thing? Okay. That needs little bit of logic, but if your logic is strong, the third method I'm going to tell you, going to solve the questions in seconds. Dhyan dena. Let us add R1 and R3. Okay, so what is 1 plus 7? 8. 2 plus 8? 10. 3 plus 9? 12. And look at the relation with the R2. Look at the relation with the R2. It is twice. 4 twos are, 5 twos are, 6 twos are. So dear, I can say that whenever I add R3 and R1, I get 2 R2. Dependency. I get 2 R2. I get 2 R2. Or I can say that R2 is equal to R1 plus R3 is divided by 2. R1 plus R3 is divided by the 2. R1 plus R3 is divided by the 2. R2 is equal to the R1 plus R3 divided by 2. Right, everybody? Right, everybody? If M is equal to 2 in last row, then also it is echelon. Increasing hona chahiye na, Hania? Okay. So there is a dependency. So out of the 3 rows of the matrix, dear, 1 is dependent, right? So you have one dependent row. So how many? 2 independent rows. If you have 1 dependent rows, remaining 2 are independent rows, and rank is equal to number of independent rows or independent columns. You can either check by rows or you can either check by column. That is one of the point I've mentioned in the beginning. Okay, I told you very, very important point. Let me highlight this. This is a very, very important point for many of the questions. Rank of a matrix is always equal to number of linearly independent rows or equal to number of linearly independent columns. Number of linearly independent rows or equal to the number of linearly independent columns. Right, dear? बहुत बढ़िया. ठीक है. So that is what it is, and hence the rank is equal to 2 by the direct dependency we are able to see here. Okay, good morning, Chinmay. Okay, let's figure out more questions. Okay, what is the rank of this matrix? What is this? Is fifth one only, kya? Ha, correct. What is the rank of this matrix? Arey, the 2 rows are given identical. R3 is same as R1, so R3 depends on R1. R3 depends on R1. No. Only linear dependency, right? A linear dependency is of the form, Manjeet, AR1 plus BR2 plus CR3 equal to 0. Okay. Y equal to MX. Y equal to MX plus C bhi nahi chalega. Right. So there cannot be any constant. The rows should be dependent through their own numbers. Okay. Okay. Chalo. So this is one dependency. So how many independent rows? 2 independent rows. So rank ko mark kar dijiye 2. You can either go by the determinant method also, right? Or ऐसा कर लेते हैं ना, whatever clicks quickly. Or determinant. देखो, 2 rows are same, determinant will be 0. Whenever 2 rows are same, determinant property na, 2 rows are same, determinant 0. Okay, determinant 0, so rank cannot be 3. Rank cannot be full. Rank cannot be full. What about 2 cross 2 rank? What about a second rank? So 1, 1, 1, minus 1. I have randomly checked this 2 cross 2 minor, right? And this is minus 1, minus 2, not equal to 0, right? Not equal to 0, so rank ho gaya 2. A 2 cross 2 minor is non-zero, so rank has to be 2, dear. Rank has to be 2. Answer is 2. Everybody, answer is going to be 2. All clear? Chalo, very good. Next question. Find the rank of this matrix. Find the rank of the given matrix. Question number 6 for you. Find the rank of the given matrix. 1, 2, 4, 2, 4, 8, minus 5, minus 10, minus 20. Right, 1, 2, 4, 2, 4, 8, minus 5, minus 10, minus 20. Okay, chalo, bahut badhiya. Right, so what is going to be the R2? R2 is going to be 2R1. R2 is going to be 2R1. Right, 1 into 2, 2 into 2, 4 into 2. Okay, what is going to be R3? R3 भी देखेंगे ना, 1 into minus 5, 2 into minus 5, 4 into minus 5. Right, so this is minus 5R2. Minus 5R1, sorry. So what is the R3? Minus 5R1, isn't it? What is going to be R3? Minus 5R1. Minus 5, minus 5, minus 5 से multiply किया. So how many rows are dependent? Dear, 2 dependencies are there. 2 dependencies are there, right? So you have 2 dependent rows. There are 2 dependent rows. So there is only 1 independent row. So rank of the matrix is equal to 1. Rank of the matrix is equal to 1. Acha, so always note that. Now, in a sense, all the rows are proportional to each other. This is the case when you have row 1, then you have 2R1, and then you have minus 5R1. This is how the structure is actually. ऐसा structure बन रहा है. R1, 2R1, minus 5R1. Right? That means how many unique row is there? Only one unique row, only one independent row. Rank is equal to 1. I can say that all the rows are proportional to R1, 2R1, minus 5R1. All the rows are, right, alpha R1. All the rows are in the form of alpha R1. All the rows are proportional to R1, right? So, note this important point. Whenever all the rows, or same apply to the columns also, of a matrix are identical or proportional to each other. Identical matlab they may be same as well. R1, R1, R1. R1, 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 alpha can be 1 for all of the rows. Okay. Then, in all such case, rank of the matrix is equal to 1. In all such case, rank of the matrix is equal to 1. In all such case, rank of the matrix is equal to 1. Seventh question. Let A is equal to Aij. Okay, so I and J are belonging to 1 to n, and n is greater than equal to 3. Aij is I into j. That is the relation given. What is the rank of A? N can be any number greater than equal to 3. Now, let us try with n equal to 3. Let us try this with the n is equal to 3. Let us try this rapidly with the n equal to 3. Dekh lete hain. Let us try this rapidly with the n equal to 3, and please pay attention here. N equal to 3. What should be the rank of the matrix? What should be the rank of the matrix? So for n equal to 3, what is the matrix? It's a 3 cross 3 matrix. Now, all the elements Aij is I into j. This is A11. This is 1 into 1. Right? This is A12. This is A13. This is A21, A22, A23. Then we have A31, A32, A33. Right? If I simplify this, the matrix A actually becomes 1, 2, 3, 2, 4, 6, 3, 6, 9, 3, 6, 9. Right? So how much this is? Into 2. Right? This is 2R1. How much is the last one? 3 times. 1 into 3, 2 into 3, 3 into 3. This is 3R1. Right? All the rows are proportional to each other. All the rows are proportional to each other. So rank is equal to 1. Only one independent row. All rows are proportional. R1, 2R1, 3R1. All the rows are in the form of alpha R1. And all such cases rank will be 1. All such cases rank will be 1. NAT type question as a homework, because it is on the similar concept. 1 or 2 homeworks also I'll keep adding. Okay. This one is a homework for you. Right. This one is a homework for you. Next question. Let's move ahead to the next question here. Find the rank of the matrix. It's a 3 cross 4 matrix, non-square matrix. Think about this and get me the rank. And by the time, let me just take the charger as well. Just a minute. Yes, guys. Chalo. Okay. Now, I told you the dependency method which I'm talking is applicable on rows as well as columns. Dekho, I'll show you that. Yes, Manjeet, very good. Sometimes you may not be able to find a dependency between the rows. You may not be able to find, there will be dependency, but you are not able to find, because dependency is any dependency. Kabhi kabhi aisa bhi ho sakta hai. Suppose there may be a dependency of the form 5R1 is equal to 11R2 plus 99R3. What will you do then? Maybe this is also a dependency, na? This is also a dependency. Right? So there can be sometimes, complicated dependency. Dekho, so here you are not able to figure out the dependency does not mean that there is no dependency. So don't comment that the answer is 3. Either confirm by Echelon form. If you are not able to find a dependency, either do the Echelon method. Either go for the Echelon method. If not, go for the columns also. Columns bhi to hai. Columns bhi to hai, right? Right. So if I take this as the columns C1, C2, C3, C4, clearly, right, these are related as double. 2 into 4, 3 into 2, 2 into 2, 3 into 2, 1 into 2. So they are related as double. Column number 1 is twice of column number 2. It is twice of column number 2. One relation is here. Okay. Next, add these two. 2 plus 1 equal to 3. 3 plus 4 equal to 7. 1 plus 0 equal to 1. So I can write down that C2 plus C3 is equal to C4. Right. What is the result? That I have clearly two dependent columns. Right. C2 is dependent on C1. C4 is also dependent on C2, C3. Right. So we have two dependent columns. Right. So we have total 4 columns. So 2 independent columns. Right. So rank is equal to 2. Rank is equal to number of independent rows or independent columns of the matrix, applicable to both rows and columns. ये ध्यान रखना है आपको. Applicable to both rows and columns. Applicable to both the rows and columns. Okay, the rank of the matrix will be equal to 2. Rank of the matrix will be equal to 2. Okay. Find the rank of this given matrix. Chalo, this one, put it as this is a simple question. You can even solve by the basic determinant method. This is a homework. Told you na, similar type of questions homework denge. Let us understand all variety of questions of rank and linear system of equations today. Right. Consider a n cross n square matrix. Find the rank of adjoint. So this is a last moment of time. There is no need of derivation. Okay. There are some standard results which I will give you. Derivations you want, you can try at home. Okay. Baki rest, concept and logic and calculations, everything I'm explaining you. Right. What is the rank of adjoint A? What is the rank of adjoint A? What is the rank of adjoint A? If the rank of n is equal to, if the rank of A must be given to you, right? If the rank of A is equal to n, then the rank of adjoint A will also be n, right? Because if rank of A is equal to n, then it is the full rank case. Then the determinant of the matrix is non-zero and determinant of adjoint A also will be non-zero. Okay. Next, if the rank of A is equal to n minus 1, if the rank of A is equal to n minus 1, then the rank of adjoint A is 1. Directly it is 1. And if the rank of A is less than n minus 1, any value less than n minus 1, you can simply understand logically, na, if the rank is less than n minus 1, matlab all minors of n minus 1 size. Think, all the minors of n minus 1 size are 0. How do you build an adjoint? Adjoint is built by cofactors. Cofactors depends on minors. Cofactor depends on minors. If the rank is less than n minus 1, so all minors of n minus 1 would be 0. Na? If there was a n minus 1 minor non-zero, then the rank will be n minus 1. I say that, just remember my logic, Hania. If the rank is less than n minus 1, all minors of the size n minus 1 will be 0. That means all cofactors will be 0. All cofactors will be 0. So what do you get in the adjoint? Nothing. All the elements of the adjoint matrix are 0. It is a null matrix. It is a null matrix and hence rank will be 0. And hence the rank will be 0. So whenever the rank of A is less than n minus 1, adjoint of A will be a null matrix. That is why the rank will be 0. Rank equal to 0 only for a null matrix. What is a null matrix? All elements are 0. Okay. So these are the three conditions. If rank of A equal to n, adjoint A also will have the rank n. If rank of A less than n minus 1, adjoint A is a null matrix, so rank will be 0. If rank of A equal to n minus 1, rank of adjoint A turns out to be 1. This has a simple, these two are clear by the logic. This is a simple mathematical derivation, but no need of derivation right now. Let's focus on the questions. Okay, guys. So just remember, it is a standard result. Now they can give you any value. Here I have generalized n cross n. They can give you any value and ask you the question. Okay, they can give you any value. Suppose they can give you a question like this. A is a 5 cross 5 matrix and rank of A is given to be 3. What is the rank of adjoint A? They can give you questions in the numeric form. What is the rank of adjoint A? NAT type question. So tell me what should be the answer. Right. So rank of A jo given hai na, that is equal to 3, but that is less than 5 minus 1. That is less than n minus 1. That is less than n minus 1, right? So what is going to be the rank of adjoint A in that case? Rank of adjoint A will be 0. Adjoint A will be a null matrix. They can put it into numbers. They can frame the question into numbers. I have given you the general results. Right? Okay, before we move to the next question, a quick reminder that this session is going to come for you tomorrow. Right? Last 3 months, more than 3 months, around 100 days you can say. Last 100 days around are left for the GATE examination. Okay. If you have any of the doubts regarding to the preparation, regarding to your practice, what should be the revision plan now, how many hours to study now. Now it is the crucial time. Now no compromise with the number of hours. What is the right time to start test series, especially the mock test, and is 75 plus possible now? Get answer to all your, if you have any of these doubts, do join me live tomorrow 8 p.m. This is tomorrow night at 8 p.m. Join me live and we'll rectify all your doubts. Okay, let's move ahead to the next question. Number 12. Next question, number 12. The system AX equal to B has a unique solution if. Now, let me test how many of you remember. I'm going to review all of that, the results you need to remember. Now, whatever we have done in the rank till now. Okay. Yeah, sure, Hani, I will try. If this is helping you, I'll try. Do not forget to like the session. Keep liking the session, guys. Okay. So, whatever 11 questions we have discussed for the rank will be used here also. Rank will be used even in the system of equations. But whatever questions we have done with the rank, whether it is determinant method, it is the Echelon method, Echelon Form method, or it is the dependency, independency method. All questions of rank will be simplified. Don't worry. You have covered everything with respect to rank. Okay. And that is why I'm bringing you a question express type of series. Question bhi cover kar rahe hain, and I'm explaining you the methods and concepts as well. Right. You are able to see that we are not going into, theoretical type of thing. We are not defining, we are not stating the theorem. That is not actually required here. If required, I will tell you that also. But what is required? Question, the approach of the question, and some important points. Even if you have not studied algebra, I hope this session can still get you marks in the GATE examination for the questions of algebra. Okay, don't worry. This session and tomorrow. Tomorrow we will have eigenvalue, eigenvector, 11 a.m. 11 a.m. Today was again 11 a.m. but today it was little bit, postponed for 30 minutes. Tomorrow 11 a.m. we will meet. Okay. The system AX equal to B has unique solution if what? If what is the condition true? Rank of A is equal to number of variables in the system is equal to rank of A is to B. Rank of A less than n, rank of A greater than n, rank of A equal to rank of A is to B is less than n. Tell me, anybody remembering this point? The correct answer is option number A. Rank of A and rank of A is to B, that is the augmented matrix, should be equal to number of variables in the system. Right? If you are not remembering, see, I am not getting much answers. Let us review this, then go to the proper questions. इसको review करते हैं एक बार. Linear system of equation, right? And commonly the questions can be in 3 variables, although there can be questions with 3 variable 4 equations, 3 variable 2 equations, underdetermined, overdetermined, सब कुछ cover करेंगे. Okay? But first let us focus here, right? 3 variables, right? X, Y, Z. So we have 3 equations normally for 3 variable. A11x plus A12y plus A13z equal to B1 and etc, etc, etc. First of all, we write down into the matrix form where this is the matrix A. Matrix A is known as matrix A is here known as the coefficient matrix. The matrix A is known as the coefficient matrix. The matrix A is known as the coefficient matrix. right? It contains all the coefficients. First equation, coefficients in the first row. Second equation, coefficients in the second row. Third equation, coefficients in the third row. Okay. Multiplied by the unknown vector x that contains x, y, z variable is equal to the constant vector b, b1, b2, b3, right? And we write this as ax equal to b. We write this as ax equal to b, right? Now, most 99.9% chance the question in GATE will not be finding x, y, z. They don't bother what is x, y, z. They only try to test whether you know whether the system has unique solution, infinite solution, no solution. I will tell you method, I will tell you trick. Like for rank also we discussed the tricks. The tricks were related on dependency and independency. Similarly, here I'll also add some tricks based on dependency, independency, but first the method. Okay, first the method. So already I told you A is the coefficient matrix. We form another matrix, A is to B, or this is also written as A slash B, or this is also written as something like this. All of this means augmented matrix. Augmented matrix means when two different matrices are combined together to form a larger matrix. Okay, so this part is the matrix A. I am augmenting, I am adding the column of B here. This is known as the A is to B matrix, and this is of the size 3 cross 4. The A matrix was of the size 3 cross 3 for 3 variable system. Rauch's theorem says that a system is consistent. What is the meaning of consistency? What is the meaning of consistency? That means the system will provide some solution. System will provide some solution. It may be one solution or more than one solution, right? But it will provide some solution. But system is consistent if the rank of coefficient matrix is equal to rank of augmented matrix. Rank of coefficient matrix is equal to the rank of augmented matrix. Rank of coefficient matrix is equal to the rank of augmented matrix. Okay, dear? Rank of coefficient matrix is equal to rank of augmented matrix. Let us, I told you the theorem ke hisab se nahi, let us understand by the flow chart. It is easy to remember. So you have Ax equal to B, where n is the number of variables. If rank of A is equal to rank of A is to B, suppose it is equal to R, if both these ranks are equal, then the system is consistent. System is consistent if rank of A equal to rank of A is to B. So, if the two ranks are not equal, rank of A does not equal to rank of A is to B, then the system is said to be inconsistent. Then the system is said to be inconsistent and the system will have no solution. The system is said to be inconsistent. Inconsistent means the system cannot give you any solution. That is the case of no solution. But if the system is consistent, it will give you some solution. It may be unique, right? It may be unique or it may be multiple solutions, many solutions. Whenever rank of A equal to rank of A is to be equal to the number of variables, then the system has unique solution. But if both the ranks are equal, both are equal but less than the number of variables, then the system has infinite solutions, right? That is what the first of the question was asking you. System has unique solution if rank of A equal to rank of A is to be equal to n, equal to number of variables in the system. Equal to number of variables in the system. This is a flow chart to be remembered. Then slowly I will keep adding the tricks. Okay, slowly I will keep adding the tricks. Homogeneous pe bhi aayenge. Let us complete the non-homogeneous case. Then we will come to homogeneous. We will cover homogeneous also today. Linear system of equation means both. Right? Okay, non-homogeneous if B not equal to 0. Right. Number 2, we will cover homogeneous as well. Homogeneous with when B equal to 0. Right. Homogeneous when B equal to 0, Ax equal to 0. So both will be covered. That is also important. Both are important. Okay? Right. This is the flow chart to be remembered. Now, let us separate out the unique solution. This is important for question and this is a direct trick. For unique solution, the method says rank. But I will never use the rank for unique solution. I am going to make it simple. For unique solution, I am going to make it simple. Chalo isko alag se samajhte. Forget. Whatever is written, forget. Okay. For unique solution, rank of A equal to rank of A is to B equal to n. That is what is the condition for unique solution. Hai na? If this is the condition, dear, for the unique solution, all the three are equal. So eventually rank of A is equal to n. Eventually rank of A is equal to n. A is a n cross n matrix. Rank of A is equal to full. N matlab full. Right. Rank equal to full if the matrix is non-singular. The very first thing we have studied today only, na? If the matrix is non-singular, right? So for unique solution, you only have to check determinant, Baba. No rank. This comes to a determinant question. This comes to a determinant question. Same thing I have written here, right? Same thing I have written here. Okay. If the coefficient matrix, which is A, if the coefficient matrix is non-singular, then the system will have unique solution. Acha, if the determinant of A does not equal to 0, na? Right? If the determinant of A does not equal to 0, then the inverse will exist. Then the inverse of the matrix will exist, because A inverse is given by the formula adjoint A divided by modulus of A. So if the determinant of the matrix is non-zero, then you can also calculate the inverse of the matrix. And if you can calculate the inverse of the matrix, you can also determine X. AX equal to B. So X will be A inverse into B. X will be A inverse into B, right? But I told you, na, 99.9% chance they are not going to ask what is X, what is the XYZ variable. They only try to test whether you know to determine unique solution, no solution, infinite solution. Okay? Chalo. Now let us turn back to a question. Okay, यहाँ पे थोड़ा सा question का mixing करते हैं. Just wait for a moment. Oh, slightly mix the questions here for better understanding. यहाँ तक हमने किया है. Chalo. Kindly take this question. I'll just mix. Don't worry about the numbering. All 51 will complete karenge, but I'm just mixing the questions here. For what value of K the system of equations has unique solution? So starting with the simple one. Starting with the simple one. Unique solution के लिए condition बताओ. तो unique solution is very simple. The most simple, the most simplest. Determinant of it does not equal to 0. Right? So determinant bole to 1, 1, 2. Determinant of what? Coefficient matrix. So only write down the coefficients of x, y, z. So 1, 1, 2. Then you have 1, 2, 4. You have the 1, 2, 4. You have then 1, 3, 1. The 1 and 3 and 1. This should be not equal to 0. This should be not equal to 0. ठीक है? Okay. So कितना हुआ? 1 into 2 minus 12 minus 1, right, into 1 minus 4 plus 2 into 3 minus 2. This should not, where is the K? I'm sorry. K, sorry. ये K miss हुआ. This K I have missed out. Okay, just a moment. That is how I felt. ये तो calculation में चला गया. Okay, so I'll just redo the calculation. 1 into 2K minus 12 minus 1 into K minus 4 plus of 2 into 3 minus 2. This is not equal to 0. So this means 2K minus 12 minus K plus 4 plus 2 does not equal to 0. So this is going to let 2K minus K is K, and this is not equal to 6. K minus 6 bacha, so K does not equal to 6. What is the correct answer then? All values. K can take any value, but it should not be 6. So all values of K except 6. This is the simplest question, and this is a type of expected question. For what value of K the system has unique solution? All clear? For what value of K the system has unique solution? For what value of K the system has unique solution? Moving ahead to the next. Right? No, today 51 nahi, total 51 questions into 2 parts, Hania. Total 51 questions of linear algebra, where today I will cover rank and system of equations. System of equations means non-homogeneous also, homogeneous also. Tomorrow I will cover very, very important eigenvalue, eigenvector. Combining today and tomorrow 51 questions. Right? So today around 25, I don't know exact kitna rakha hai maine. I made the PPT morning only, but I don't know what is the exact number, but somewhere around 25, 27 questions will be today. Next will be tomorrow. Okay. To total 51 of algebra. Okay. So K is not equal to 6. This is one simple question. Okay, dear. This is one simple question. Now let me shuffle up. Yeah. Let me come to this question now. Consider the following system of linear equations. Consider the following system of linear equations. 1, 2, minus 8, 4, 3, minus 12, 2, 1, minus 4, x, y, z is 7, 5, d. How many values of d does the system has no solution? For how many values of d does this system has no solution? For how many values of d does this system has no solution? Right? System has no solution. No solution का case यहाँ पे solve करना है. Right? First of all, I will add on shortcuts also. Let me just apply the proper method first. Okay. First of all, let us take the matrix A is to B. And that is going to be the matrix 1, 2, minus 8, 7. Then 4, 3, minus 12, 5. And 2, 1, minus 4 is 2D. That is what it is. Okay. Okay. Right. Now, the system has no solution if rank of A does not equal to rank of A is to B. I have written both the matrix together because for rank here, one of the value is unknown. So for rank, I will go to Echelon method. For Echelon method, we need to apply elementary transformations, elementary row operations. And if I apply elementary row operations on A is to B, automatically it is applied on A also. Okay, so we will take it as only one activity. Okay, अब क्या करना है? First of all, I want to increase the number of zeros. So this has to be 0, this has to be 0. Right? ये कैसे होगा? The first step that you're going to write is R2 minus 4R1. After this, I will add the trick. Okay? Just wait. After this, I will add the trick. Okay? And similarly, R3 will be R3 minus 2R1. R3 minus 2R1. So how much is the A is to B? How much is the A is to B? 1, 2, minus 8, 7. Right, 4 minus 4, 0. 3 minus 2 into 4, minus 5. 3 minus 8. This is also multiplied by 4. So minus 32 and this becomes total 20 is 2. 5 minus 28 minus 23. Some random numbers are coming, but no problem. We'll deal with this. This is 2 minus 2, 0. 1 minus 4, minus 3. This is 2, so minus 16, and this is total left as 12, and then this is D minus 14. Okay. Now again to convert into the Echelon form, dear. Again to convert into the Echelon form. पहले तो हमने इसको और इसको 0 किया. Now I want to increase the number of zeros. It should be increasing order. Here there is no 0, single 0. Then here I want 2 zeros. Here I want 2 zeros. Right. So what is the next number to be converted to 0? This is to be converted to 0. So what I will do? This I have to multiply by 3 by 5. R2 has to be multiplied by 3 by 5. 5 will cancel. Then minus 3 same. Then you can subtract and you can make it as 0. Then you subtract and you make it as 0. So what is the thing that I am now going to do? R3 will be R3 minus 3 by 5 R2. Thoda sa teda calculation hai, but yeah, we have to be ready for, sometimes unusual calculation also. R3 is R3 minus 3 by 5 R2. So doing this, what I get? Doing this, how much I get? After this, what is the matrix I'm going to get? Let me write down here only. Let me write down the here only. 1, 2, minus 8, 7. Then you have 0, minus 5, 20. Just keep checking the calculation, okay? If there is any calculation correction, you can also suggest me. Then this is 0. This becomes 0. अब इसको 3 by 5 से multiply करेंगे. Multiplying by 3/5, it becomes 12. It becomes 12. So 12 minus 12. This is also 0. Very good. Multiply this by 3 by 5. ये है. ये सही तो है ना? Yeah. Now multiplying this by 3 by 5. See what you are going to get. D minus 14. Minus 3 by 5 of minus 23. Minus minus plus हुआ तो D minus 14. And plus how much? Plus 69 by 5. Okay, so you are eventually getting D minus, ये हो गया 70 plus 69 by 5. So D minus 1 by 5 actually. So you are going to get D minus 1 by 5 total. Right? That portion is D minus 1 by 5. So here what I am getting is D minus 1 by 5. What I am getting is D minus 1 by 5. Clear everybody? What I am getting here is D minus 1 by 5. Okay. Now, how many values of D does the system has no solution? No solution. Now, let me write down this matrix actually once again so that I can explain you 1, 2, minus 8, 7. Check the calculations once, okay? 1, 2, minus 8, 7. Then you have 0, minus 5, 20. Minus 23. Then you have 0, 0, 0, 0, 0, 0. D minus 1 by 5. Everybody. Now everybody, please track this matrix. This is the A matrix. This much portion is A matrix and this is the A is to B matrix. In the A matrix, if I talk about number of zeros, it is nil, then 1, then 2. 0, 1, 2. Right? This is increasing. This is increasing. This is echelon form. This is the increasing form, echelon form. And if the matrix is in echelon form, rank of A is equal to, forget this, abhi isko dekhna hi nahi hai. Right? For a moment, don't see this. Okay. So what is the rank of matrix? Number of non-zero rows. This is 0. 2 rows are non-zero. 2 rows are non-zero. Rank of A is equal to 2. But what is the condition, dear? What is the condition, dear, for no solution? The question is asking no solution. What is the condition for no solution? What is the condition for no solution? Think about this. What should be the condition for no solution? The condition is rank of A should not be equal to rank of A is to B. Okay, if rank of A equal to 2, ab dekho dhyan dena. Have a look into the M here. Have a look into the M here. 0. Have a look into the M here. 1. Overall M. Overall number of zeros in the entire A is to B matrix. What is the number of non-zero elements? Starting zeros here. What is the number of starting zeros? 3 to hai. 3 to hai. Right. 3 to hai. But it can be fourth one as well. It can be fourth one. So minimum 3. Right. Minimum 3. Right. Or 4. Right now I am able to see 3 or 4 depending on D minus 1 by 5. Right. So echelon form to hai. This is clearly echelon form. Increasing trend hai. So this is echelon form. Right. So what is the rank of A is to B? What is the rank of A is to B? Number of non-zero rows. This is non-zero. This is non-zero. If D minus 1 by 5 isko maine 0 kar diya, then what do you get? Dekho, to yahan pe dhyan dena. I'll write down clearly. Right. Rank of A is to B, dear, if D minus 1 by 5 equal to 0, then what is the rank? Everybody understand. If D minus 1 by 5 is 0, this is row of 0. So how many non-zero rows? How many non-zero rows? There are 2 non-zero rows. There are the 2 non-zero rows. Everybody. There are the 2 non-zero rows. But if D minus 1 by 5 does not equal to 0, right? Suppose this is not equal to 0. Suppose this is 2. Suppose this is 2. So how many non-zero rows? How many non-zero rows? 1, 2, 3. Then all are non-zero, na? Ye bhi non-zero ho gaya. Ye bhi non-zero ho gaya. Correct? All are non-zero rows, right? Now, the question is asking you no solution. Dhyan dena. For no solution, for inconsistency of the system, rank of A should not be equal to the rank of A is to B. Rank of A should not be equal to the rank of A is to B. बहुत ही बढ़िया. Rank of A should not be equal to rank of A is to B. Then what it should be? Rank of A should not be equal to rank of A is to B. Then what it should be? क्या होना चाहिए? Then what it is going to be? Have a look into this. What it is going to be? Rank of A should not be equal to rank of A is to B. So what it should be? Okay. Rank of A is 2. So rank of A is to B for non-equal, it should be 3. That means D minus 1 by 5 not equal to 0. So D does not equal to 1 by 5. Correct? D does not equal to 1 by 5. Right? So, for question में क्या बोला है? How many values of D? भाई आंसर क्या निकला? How many values? So D can take any value. D can take any value except 1 by 5. D can take any value except 1 by 5. So except 1 by 5, how many numbers are there in the world? How many real numbers are there in the world? Infinite number of values are there in the world. Right. All okay, dear? All okay? This is how you should understand the problem. Okay? Acha, let me add on one more thing here. Right? Suppose if d is equal to 1 by 5. If d minus 1 by 5 is 0, so d will be 1 by 5. Then the rank of A equal to rank of A is to be, that is 2. Okay. Then I will say rank of A equal to rank of A is to be, that is 2. Then what is the type of solution? Everybody? Then what is the type of solution? All dear, what is the type of solution then? Then what is the type of solution? Infinite. Yes. Rank of A equal to rank of A is to be, but less than the number of variables. भाई number of variables 3 है ना, यहाँ पे n का value 3 है. Both the ranks are equal but less than number of variables. Then the system has infinite solutions. Right. For only a single value of d, the system will have infinite solutions. ठीक है. अच्छा, if you go and check this determinant ना, this determinant will be 0. That is why unique solution होगा ही नहीं. It will never have the unique solution case. This determinant will be 0. It will never have the unique solution case. It will only have either infinite or no. Right? So if d does not equal to 1 by 5, no solution. This one, no solution. If d equal to 1 by 5, then you have infinite solution. Unique solution not possible here because determinant of A, please check it out, it is going to be 0. Quickly you can check, it's going to be 0. Okay. Chalo. Right. So no solution question bhi humne kiya. Now everybody, let's keep rolling. And have a look into this question. The following system of equations will have what type of solution? अब मैं यहाँ पे आपको ट्रिक भी बताऊंगा. Following system, this question I will introduce the trick, but let me solve it regularly first. Okay, regularly, what is the A is to B matrix? 1, 2, 1, 6. 2, 1, 2, 6. 1, 1, 1 is to 5. 1, 2, 1, 6, 2, 1, 2, 6, 1, 1, 1, 5. Okay, what will the system of equations have? Okay, देखो, very simply, let me start with the Echelon method once again. Okay, I need to convert first this into 0. I will apply clearly R2 is equal to R2 minus 2R1 and R3 is directly R3 minus R1. Both are same, 1 and 1. Okay, subtract kiya. So what is the matrix now? 1, 2, 1, 6. Right, 2 minus 2, 0. 1 minus 4 minus 3. 2 minus 2 again 0. 6 minus 2 into 6 minus 6. 1 minus 1, 0, 1 minus 2 minus 1, 1 minus 1, 0, 5 minus 6 minus 1. Okay, now again for Echelon form, I need to increase the number of zeros. Nil, then 1, and then this also has to be 0 for increasing number of starting zeros. Right? Okay, so what is the next step I will do now? Next step that I will do now is multiply R2 by 1/3. Multiply R2 by 1/3. इसको 1/3 से multiply किया, and then this becomes minus 1. Then I can subtract. Okay. After doing this, see the matrix that now comes 1, 2, 1, 6. Right. 0, minus 3, 0, minus 6. Right. 0, 1/3 से subtract किया, 0, 0. Here also, you multiply 1/3. This becomes minus 2. Minus 1 minus of minus 2 will be plus 1. Okay, now number of starting zeros are in the increasing order, no problem. What is the rank of the A matrix? Everybody, what is the rank of A matrix? How many zero rows? How many non-zero rows, sorry. For the A matrix, look into this much part. Isko chhod dijiye. Look into this much of part and see the answer. Right. Rank of the matrix is number of non-zero rows. Only 2 non-zero rows. 3 kahan se aayega? Nahi. Only 2 non-zero rows. Right. only 2 non-zero rows. The rank of A is equal to 2. Rank of A is to B. Even the bigger matrix, both are in the echelon form, na? Starting zeros is 0, 1 and 3. Increasing order. Strictly increasing order. Okay. How many non-zero rows? Non-zero. This is non-zero. This is also total non-zero, na? You cannot call it as row of 0. A is to B, matlab you have to see the entire row up to this point, and this is a non-zero row. This is a non-zero row. So how many non-zero rows in A is to B? How many non-zero rows in A is to B? 3. It is 3, right? So system has both the ranks mismatch, just like the previous question. Both the ranks mismatch. The system has no solution. The system has no solution. Option number B is the correct answer here. The system has no solution, right? The system has no solution here, everybody. Chalo, cool. The system has no solution. Very good. Okay, अब देखो इसका shortcut क्या होगा? Have a look into the shortcut directly. Have a look into the shortcut. The following system of equations will have what? Okay, shortcut देखेंगे. Method number 2. Let me rewrite the equations. Okay, x plus 2y plus z is equal to 6. 2x plus y plus 2z is equal to 6. X plus y plus z is equal to 5. Okay. See, if I add equation number 1 and 2, na, dependency, like the rank, shortcut was dependency. यहाँ पे भी dependency देखेंगे. When you add these two, so 3x, 3x, 3y and 3z, all of them becomes 3, 3, 3, right? So when you add 1 and 2, you get x plus 2x, 2y plus y, z plus 2z. And right hand side 6 plus 6 equal to 12. 3x plus 3y plus 3z equal to 12. 3x plus 3y plus 3z equal to 12. What is going to be x plus y plus z? What is going to be x plus y plus z? 12 is divided by 3 and that is 4. 12 is divided by 3 and that is 4. Right. Now, equation number 1 and 2, look into this. Equation number 1 and 2, when you combine, they say x plus y plus z should be 4. Sum of x, y, z should be 4. But equation number 3 क्या बोलता है? Equation number 3 says that no, x plus y plus z should be 5. So you are wrong. Okay, you are wrong. Because equation number 3 says that x plus y plus z should be 5. So what is this? This is known as the case of contradiction. Everybody, this is known as the case of contradiction. Right? This is what is known as the case of contradiction. This is what is known as the case of contradiction. They cannot agree to each other, na? Okay, so if what is the meaning of linear system? Simultaneously solving linear system of equation. That means we need to find x, y, z. That means we need to find x, y, z, which will satisfy all the three equations. Which will satisfy all the three equations. So if you have x, y, z which satisfy first and second equation, it can never satisfy the third. Or if you select x, y, z, satisfying the third equation, it can never satisfy first and second. That means there is no value of x, y, z which can satisfy all at a time because they are contradicting. They are fighting each other. They are contradicting. They are fighting each other. And whenever you have the contradiction, you have no solution. Whenever you have contradiction, you have no solution, right? Whenever you have contradiction, you have the no solution. You have the no solution, right? Whenever you have the contradiction, you have the no solution. All okay? For contradiction, you have no solution. Chalo. Right, remember this is also a direct way of solving it. This is also a direct way of solving it. Chalo. Now, guys, take up this question. With this question, let us find out the values of lambda and mu for which the system has unique, infinite, no. All the three cases, let us quickly revise through this question and then move to the next category. then move to the next category. Guys, I just need 5 minutes of time, so please solve it up. Solve. I'll be back in 5 minutes. Okay, it's not a break or it's not a halt, but I'll just need 4 or 5 minutes. I'll come back. Okay, I'll just have some coffee or something. I'll just come back. Okay. Okay, I'll be just back in 5 minutes. Stay tuned. I'll just have some coffee or something, and I shall come back very shortly. I need something for my throat. Right? 5 minutes, just 5 minutes maximum. I'll come back. Okay. Please solve it up. I need your answers by that time. I'll come and start solving immediately. So please solve it up. Okay. चलो right. Chalo guys, so let's continue forward now. Okay, yeah. Thanks for the coordination. We have stopped for 5 minutes and now we are ready to begin up. Okay, some students lost the track in between, some students left or what? Check karte hain. Unique, infinitely many solution and no solution. Unique is the first and the simple case. Okay, unique is the first and the simple case. Unique solution directly determinant not equal to 0. Determinant not equal to 0 means you have 1, 1, 1, you have 1, 4, 6 and you have 1, 4 and lambda. The determinant of this not equal to 0, determinant of the coefficient matrix. So it's going to be 1, 4 lambda minus 24 minus 1 lambda minus 6 plus 1 into 4 minus 4. This is total not equal to 0. So 4 lambda minus 24 minus lambda plus 6 not equal to 0. So 3 lambda not equal to 18, lambda not equal to 6. Please check out the answer. Lambda not equal to 6. Right. Lambda not equal to 6. Is it the answer for unique solution? For unique solution, lambda not equal to 6. What about mu? Sir, for unique solution, only coefficient matrix determinant will matter. There is no role of the mu, right? So what is the answer for unique? What is the answer for unique, right? Lambda not equal to 6. Mu can take any value. Mu can be any real value. Mu can take any value. No, it is not that mu same hona chahiye. No. There is no condition on mu. No, guys. For unique solution, there is no condition on mu. Hoga hi nahi na. It only depends on the coefficient matrix. If the determinant is non-zero, 100%, it is a unique solution case. Mu can take any value. Mu can take the any value. Mu can take any possible value. Everybody, mu can take any possible value. Chalo, great. Let's go to the next. Infinite and no solution. Infinite and no solution. Ab dekhte hain yahan pe. Let me rewrite the numbers. I'll solve it up together. X plus y plus z equal to 6. I'll solve it through the shortcut now, which we have already discussed. X plus 4y plus 6z. X plus 4y plus 6z is 20. And next is x plus 4y plus lambda z is equal to mu. Ab dhyan dena yahan pe. Right. X plus 4y. This much of the portion is common to both. Right. X plus 4y. This much of the portion is common to both. This much of the portion is common to both. Right. Suppose if this is common, the left hand side will be totally equal. Suppose if this is common. Right. Understand through a simple logic. Okay. So if lambda I take it as 6. If lambda I take it as 6. Logic se solve kar rahe. No need of any rank calculation. Logic. Shortcut. Lambda equal to 6. But mu not 20. So dekho, if lambda is equal to 6, x plus 4y plus, what will be the equation number 3 then? X plus 4y plus lambda z, that is plus 6z equal to mu, but mu is not 20. So right hand side is not equal to 20. Equation number 2 bolta hai equal to 20. Equation number 3 there is not equal to 20. Right. What will happen? What will happen? Right. This is 1, 2, 3. What will happen? It becomes the case of contradiction again. And for contradiction, you have no solution. For contradiction, you have no solution. Finished. No need to apply rank method. Direct shortcut. Okay. Right. No solution. Now, Prashant, why do you even want to look into A is to B? If rank of A equal to 3, rank of A is to B will also be 3 only, na? A is a part, A is a subpart of the A is to B matrix. That way also you can understand, Prashant, okay? So no solution directly. So for no solution, lambda is equal to 6, mu is not equal to 20 is the answer. Acha. Next. Suppose lambda equal to 6, mu also equal to 20. Lambda 6 bhi hai, mu 20 bhi hai. Then what happens? Then what happens? Equation number 3, x plus 4y plus lambda z is equal to 20. Equation number 3 is equal to equation number 2. So there are only 2 equations, right? Okay. Yes, Prashant. This is non-homogeneous only, Sanjay, Surya. Okay. So, there are dependent equations. Total equation is dependent. Total equation is dependent. Correct. So, what is the race? What is the result? What is the result? Okay. There are three variables, but there are only two equations. There is no third equation. The third equation was just written to fool you. If lambda is 6, mu equal to 20, there is no third equation. There is no third equation. So, system will give you infinite solutions. Right? To solve for three variables, you need at least three independent equations. So, system will give you infinite solutions. So, dependency mein, system will give you infinite solutions. Infinite solutions. If you go by the rank method, right? If you go by the rank method, then what you can say? Rank of A and rank of A is to be, both will be equal and equal to 2. Equal to less than number of variables. But no need of rank method. Apply these shortcuts. Apply these shortcuts. So for infinite solutions, this is the answer. For no solution, this is the answer. For unique solution, determinant method, that is the answer. All three answers are written. Right? So guys, now, for most of the questions, I have made the process simple. Everybody just quickly recall, revise. Unique solution, only one calculation, determinant not equal to 0. No solution, contradiction. Infinite solution, dependent equations. If you apply these three tricks and these three logics, then most of the questions are simple. Okay, although we have solved in details also. Okay, now I'll give you, it's a gate question for reference, just to show you how easy it is. Please take this as homework. Infinite solutions. Think about dependency. कैसे solve करेंगे? The trick is not about the rank method. Trick is dependency. Dependent equations. Try to see dependent equations. Try to make dependent equations. Very clearly you will get the answer within few seconds. If you think about dependency, it's a 2-mark question. I want you to try. That is why I'm not discussing, and intentionally I'm giving you a gate question as homework for reference. Otherwise, rest were different questions. This I have shown you by the proper rank method. ये पूरा rank method से हमने discuss किया था. Okay, how we got the no solution by the Rauch's theorem. Complete rank of A is to B. Okay. Next question. Before we go to next question. Okay, let me also tell you the password for today's PDF. Okay, there are few more questions left for today, but before that I'll share you the password for today's PDF. Yes guys, I'm going to share you the PDF. In my Telegram group. The PDF is going to be password protected, and the password is going to be LA_part1. A simple password I have framed today, LA_part1. For tomorrow does not mean that it's going to be password as part 2. Tomorrow it will be something else. But for today, LA_part1 is going to be the password for today's PDF. You can download from my Telegram, put the password, and then you can access the PDF. Without the password, you can't access the PDF. Okay, next question. Consider the following system of equations. X plus 2y minus 3z equal to 0. X minus y equal to 0. 2x minus 4y plus 2z equal to 0. Determine whether the system has trivial or non-trivial solution. Okay, so see, 0, 0, 0, right hand side everything 0. So I am turning now to, when all the right hand side coefficients, all the right hand side constants are 0, we call this system as homogeneous. Already I defined in the beginning, this is known as homogeneous system of equation. Have a look into this, right? Ax equal to b. If b is null, we get ax equal to 0 or ax equal to null, and that is what is known as homogeneous system of equation. All right hand side coefficients are 0. All right hand side coefficients are 0. So what all you need to know about the homogeneous? What all you need to know about the homogeneous system of equation? वो यहाँ पे समझ लेते हैं. What all you need to know about the homogeneous system of equations? Please have a look at this. Okay, this is homogeneous system of equation. Okay, now put x, y, z 0. What is the meaning of solution? Solution means the value of x, y, z which will satisfy all the three equations. So I'm trying 0, 0, 0. I'm trying 0, 0, 0. Okay, so 0 into A11 into 0, A12 into 0, A13 into 0. So it's all 0, right hand side 0, satisfied. Similarly here also 0 plus 0 plus 0 equal to 0, satisfied. 0 plus 0 plus 0 equal to 0, satisfied. So if I take x, y, z 0, 0, 0, it satisfies all the three equations. It satisfies all the three equations and hence it is a solution. 0, 0, 0 satisfies all the three equations and hence it is a solution. Hence it is a solution. Can I say na 0, 0, 0 is always a solution no matter what? Matlab this system can never be inconsistent. What is the meaning of inconsistency? What is the meaning of inconsistency? The system has no solution. But यहाँ पे तो ऐसा होगा ही नहीं. 0, 0, 0 always one solution minimum I am giving you. Guaranteed, confirmed, one solution is always given to you. The system is never inconsistent, system is consistent. Now the question is whether it has only one solution, 0, 0, 0, or it has more than one solution. Now everybody listen, if it has only one solution, if it is unique solution, listen to me clearly, if it has unique solution, means it has only one solution. But what is that one solution? 0, 0, 0. That is always a solution. Does this solution depend on the system? Right. 0, 0, 0 means x is 0, 0, 0. So x is also a null vector. So it is very logical, na? You take A matrix, you multiply by null, you are going to get null. Null means 0. A into 0 is always 0. A into 0 is always 0. Is there any new discovery, a new discussion here? That's what you know from the childhood. Multiply anything by 0, you get 0. So what is new here? That is meaningless. That is meaningless. So if the system has unique solution, means the system has only one solution. But we also know that 0, 0, 0 is always a solution. So what is that one solution? What is that one solution? 0, 0, 0. But that is meaningless. Independent of the matrix here, there is no role of the system matrix here. There is no role of the coefficient. Whatever coefficients in the world you bring, this system always have 0, 0, 0 as a solution. So whenever the system has 0, 0, 0 as the only solution, then the system is said to have, trivial solution. Then the system is said to have trivial solution. What is the literature meaning of trivial? Trivial means something which is meaningless, yeah, which is of no additional value, yeah, which is not of much use. Right? That is what is the case happening here. A into 0 is 0. What is new? Nothing new, meaningless. We all know from childhood that A into 0 will be 0. Right? So whenever the system has unique solution, it will be said to have trivial solution here. It will be said to have trivial solution here. First, let us come to this. If 0, 0, 0 is the only possible solution, then the system is said to have trivial solution. It is the only possible solution, right? So this is related with unique solution. This is related with unique solution. Now understand some more things. Okay, ye to ho gaya one point. Okay, if I again turn back to the question, I have written the question here for you once again. Look into this. This is the question given to me. 0, 0, 0 is always a solution. It is a solution. It is blindly, I can say. See, blindly looking into, looking into the coefficients, I can say that. Without looking into coefficients, I can say 0, 0 is a solution. Okay, that is waste. Okay, but here, look into this. Right, here look into this. 1 plus 2 minus 3 equal to 0. Intentionally, these equations have been framed for easy numbers. Second, 1 minus 1 equal to 0. Next, 2 minus 4 plus 2 equal to 0. Satisfied? All are satisfied. So if I put x, y, z all equal to 1, 1, 1, still I get a solution. So यहाँ से क्या मिला? 1, 1, 1 is also a solution here. 1, 1, 1. If you satisfy 1, 1, 1, it is satisfying all the three equations. That means it is a solution of linear system of equation. So 1, 1, 1 is also a solution, right? 1, 1, 1 is also a solution here. That means you have some non-zero solution here. If there are some non-zero solutions also, then the system will have said to have non-trivial solution. Okay, so non-trivial solution means more than one solution, because ये तो हमेशा बैठा है ना 0, 0, 0. This is always there. This is always fixed. You can't remove it. But other than 0, 0, 0, if you have some non-zero values also, matlab you have more than one solution. You have more than one solution. More than one solution is referred to as many solution or infinite solution. Whenever a linear system of equation has more than one solution, it will always have infinite solutions only. Okay, so non-trivial solution is related to what? Infinite solution then. Infinite solution. So have a look into the summary. Question is asking you trivial, non-trivial. The summary is trivial bole to unique. What is the condition of unique? You already have studied, na? You already have studied. What is the condition of unique? Mod A not equal to 0. Mod A not equal to 0. But then we learned that if mod A equal to 0, then the system can have infinite solution or no solution. Mod A not equal to 0 is unique confirm. Unique means trivial here. But if mod A equal to 0, system can have infinite or no solution. But in homogeneous system of equation, no solution, discarded. Already explained the first thing. There is no possibility of the inconsistency. Right? So if mod A equal to 0, what is the only thing left? Infinite solution. Infinite solution related to non-trivial solution. Question, the whole story is over. So trivial or non-trivial, it is just one determinant, no rank. This is much more easier than the non-homogeneous also. It is much more easier than the non-homogeneous also, right dear? So determinant of A not equal to 0, trivial solution. Determinant of A equal to 0, non-trivial solution. Finish. The story is so simple as compared to non-homogeneous also, right? If the system is non-trivial, just note down one more formula. The system will be having n minus r independent solutions, right? There will be non-zero solutions out of which n minus r will be independent. N is the number of variables, like 3 in the previous case. R is the rank of the matrix, which you know to calculate. Right? Right. Chalo. So, yeah, so this is what I say. This is also a solution. So here you have non-trivial. But how do you check by the method? This is explanation. How do you check by the method? Let's go back to the question. Let us go back to the question. Question mein bola tha trivial, non-trivial. I will only check the determinant of A. Whenever I see the question, I only need to check the determinant of A. So 1, 2, minus 3, 1, minus 1, Z absent is 0, 2 and minus 4 and 2. Okay, let us check this determinant. This is becoming 1, minus 2, minus 0, minus of 2, 2 minus 0. Correct? Minus of 3, minus 4 plus 2. Kitna hua ye? This is minus 2, this is minus 4, this is minus 2 into minus 3 plus 6. Yeah, it is equal to 0. Because the determinant equal to 0. Because the determinant equal to 0, system is said to have infinite, matlab non-trivial solution. The system is said to have infinite or non-trivial solutions, right? The system is said to have infinite or non-trivial solution. That's it. Question closed. The system is said to have infinite or non-trivial solution. As simple as it could be. Okay? That is why this procedure is much simpler. Okay? This procedure is much simpler. Right? Yes, this is only for homogeneous Hania. Correct? Right. Null space of a matrix. Just few more definitions and then we will complete all the questions for today. Okay. Few more questions are left. All non-zero independent vectors X which will convert the matrix A into null space, right? So dekho, we are solving homogeneous system of equation Ax equal to 0. We are solving homogeneous system of equation. All those non-zero independent vectors X which will satisfy Ax equal to 0. If they satisfy Ax equal to 0, that means what they are doing? They get multiplied by A and convert them into a null matrix. The X vector multiplied by the A convert the matrix into null matrix. All those vectors which will convert the matrix A into null matrix are said to form null space. The set of all those independent vectors which convert the matrix A into null matrix will form the null space of the matrix. And dimension means the number of elements. In brief, I am explaining because this is the question session, right? No, how many independent solutions they can ask Sivaraman? How many solutions means infinite solutions? See, non-trivial means infinite. There will be infinitely many solutions, but how many of them are independent? I'll explain you like this. Dekho, if there is any confusion, 1, 1, 1 is the solution. Dekho, dhyan dena, A into X is equal to 0, X is 1, 1, 1. But dear, if X is equal to solution, A into 2X is 2 into 0. But what is 2 into 0? That is also 0. So if x is a solution, 2x is also a solution. If x is a solution, 5x is also a solution. A into 5x, ये भी तो 0 बनेगा. So if x is a solution, 2x, 3x, 4x, 5x, 100x, 1000x, all of them are solution. Okay. So there are infinite solutions. Non-trivial means infinite solutions. Non-trivial means infinite solutions. But how many are independent solutions? They can ask that question, Shiva. Okay. Total solutions to infinite hoga. So you have to be very carefully reading that. And that is why I've given you this result. This one, where is that gone? Yeah, I mean, we are not deriving right now, but I'm giving you this result directly. There will be n minus r, important word, there will be n minus r independent solutions. Total solutions to infinite hai, but n minus r will be independent solutions. ये ध्यान रखना है आपको, right? Right. And those independent solutions, when put together, they form the null space. So what is the dimension of null space? How many vectors are there in the null space? That number of vectors in the null space is known as the nullity of the matrix. So same formula will come up here. Okay. So what is the nullity of matrix? N minus r, right? N minus r, right? So whether it is square or non-square, you just have to remember n is the number of variables. So both the formulas are okay. The nullity of the matrix is given by n minus r. N is the number of variables. R is the rank of the matrix A. R is the rank of the coefficient matrix. Since this is question session, I am giving these definitions in brief. Right. If you have any more doubts, you can refer to the detailed sessions of that, or you can discuss me later on. Okay. Chalo. Now look into this question. Look into this question. If a matrix, if a 4 cross 4 matrix has rank 2, then AX equal to 0 has how many? See, Shiva, that is what they can ask, how many independent or dependent solutions? Or does it have only trivial solution? Right. 4 cross 4 matrix, rank 2. Right. Matrix is 4 cross 4. Right. Rank of the matrix is equal to 2. That is less than 4. So determinant of A must be 0. Okay. Determinant of A must be 0. Determinant of... Oh. I'm sorry. Determinant of A must be 0, because if determinant is non-zero, Setupati, if determinant is 0, then the system will have non-trivial solution. Trivial kaise hoga, right? So if determinant not equal to 0, so non-trivial solution. Okay, so A is wrong. But in the non-trivial, how many independent solutions? How many independent solutions? Number of independent solutions is given by n minus r. N is the number of variables. So what is the number of variables? 4 cross 4 matrix. So number of variables will be 4. Right. Minus rank of the matrix they have given directly. So this is a direct actually formula based question. So answer will be 2. 2 independent solutions. Option number C. 2 independent solutions. Right. I think around almost 2 hours of session is about to be done. Many people are tired. Now the attendance has got dipped. Should we stop? If you are tired, how can I gain that energy always? Students are tired so early, I am there with full energy, right? I think we have around 25 questions for today. Exact number I don't remember, but should we stop at 1920? If A is a matrix in which all elements of A are 1, then the number of linearly independent solutions of the system. Little indirect question, but very simple. Little indirect, but very simple, right? In which all elements of A are 1. A is a matrix in which all elements of A are 1. Very simple, na? A is a matrix in which all elements of A are 1. So what is the rank of the matrix? What is the rank of the matrix? All elements of A are 1. What should be the rank of the matrix? Tell me. Right. This simply, all elements are 1. That means all rows are same. All rows are identical to each other. And if a matrix has all the rows identical to each other, what is the rank of such matrix? Everybody dear. What is the rank? That is why, see, all these topics, rank, homogeneous, non-homogeneous system are totally connected. Right. We have studied this point today only in the rank. Rank of A is equal to 1. Right. So what is the number of linearly independent solution? It is given by the formula n minus r, n minus 1, r ka value 1, answer number C. Or they can give the value of n as well. They can specify the value of n. So the answer is n minus 1. See, a good question. It is very simple, but I'll call it as good question. It is using some concepts related with the rank also. All elements are 1, so you should be able to relate rank is 1. Then you should be able to apply the formula number of linearly independent solutions, correct? That is why I call this as a better question. Chalo, next, number 21. This system has non-trivial solution if. This system has non-trivial solution. What is the condition for non-trivial solution? Modulus of A equal to 0. Trivial means unique, unique means non-zero determinant. Non-trivial means infinite, infinite means zero determinant. Simple and sweet memories. Okay, so determinant equal to 0. How simple is that going to be? Kindly complete this as homework, na yaar. It is a repetitive calculation, so better determinant equal to 0. Everybody can do it. Everybody can do it. Please do it. Determinant equal to 0. Everybody can do it. So please do it and complete it. Okay. I hope you will be able to do it. I'll put it as homework. Everybody will be able to do it. Please complete this. Okay. And whatever 3-4 homeworks I have given, do not forget to comment your answers in the comment box after the video gets over. Please do comment. Please do comment. Okay. Next question. Chalo. Let us first jump to Chalo, let's go in sequence only, no issue. This one is homework, number 22. Number 22 here. If the system x plus y plus z equal to 0, lambda plus 1 y, lambda plus 1 z equal to 0, lambda square minus 1 z equal to 0 has two linearly independent solutions, some indirect question. Yeah, I'll share, Sanjeev, I'll share, okay? Don't worry. Has two linearly independent solutions. Today I'll share up. Today I'll share both this PDF, ye wala bhi and the digital wala. Okay. Has two linearly independent solutions. What is the value of lambda? This has two linearly independent solutions. What should be the value of lambda? Two linearly independent solutions. What should be the value of lambda? Now, number of linearly independent solutions, n minus r is given to be 2, where n is equal to number of variables. So, n is 3. So, 3 minus r is equal to 2. R should be 1. R matlab rank of A should be 1. Then what is the value of lambda? The question is indirectly related to rank again. The question is indirectly related to rank. Rank of A equal to 1. What is the A matrix? What is the A matrix, dear? 1, 1, 1. Then you have 0, lambda plus 1, lambda plus 1. Right. Then you have 0, 0, lambda square minus 1. What should be the value of lambda? Here identical rows cannot be applied because anyways this is 0. 0 cannot be identical to 1. So rank is equal to 1. You can say only one non-zero row in the echelon form. The matrix should have only one non-zero row in the echelon form. Right. Rank equal to 1. So I can say the matrix should have one non-zero row in the echelon form. Non-zero row wala method only for echelon form, okay? Only for echelon form. So it should have only one non-zero row for the echelon form, right? Simple logic, simple logic. Lambda plus 1 ko 0 kar do, right? So lambda is equal to minus 1. It's a crystal clear answer in the mind. Because if I take lambda equal to minus 1, this is 0, and lambda square minus 1, this will also become 0. Both these rows will become 0. Both these rows will become 0, right? So if lambda is equal to minus 1, what does the matrix A looks like? Matrix looks like 1, 1, 1, 0, 0, 0, 0, 0, 0, right? Both the row of 0 is at the last. Okay, so it is the echelon form. Number of starting zeros एक ही row का देखेंगे. Don't count the number of ROZs. Okay, so this has the rank equal to 1. And that is what I want. So for what value of lambda? Minus 1. For what value of 0? Minus 1. Okay. This is echelon form. Okay? This is the echelon form. Row of zeros should be at the last. Now other than the row of 0, starting 0, only one row is there. So we can say it is increasing order. There is only one number. That's how there is no sense of comparing increasing, decreasing. The question is solved here itself only. Rank is equal to 1. Or you can even solve by the determinant and minor method. Rank 1 aayega. Simple one. Okay? Rank will be 1. Simple one. All great. Okay, dear? Chalo. Next question. So this is again a good question. Indirect connections. Indirect connections. Number 23. The greatest value of alpha for which the following system of equations will have non-trivial solution. Non-trivial solution. Once again, non-trivial solution. इसको चलो कर लेते हैं. Non-trivial बोले तो mod A equal to 0. Determinant equal to 0. Okay, so determinant equal to 0 means you have 1 minus A minus A. A minus 1 A. A minus 1. Let us see what is this. Is there any significance of the greatest value here? Check कर लेते हैं. Right. So this determinant equal to 0. So 1 into 1 minus A square minus it will become plus A of minus A square, then eventually minus A, then you have A square minus plus A. This should be equal to 0. Let us just solve and simplify this, right? Yes. So this is 1 minus A square, right? Minus plus A, and eventually minus, so minus ही रहेगा, minus A square minus of A cube minus of one more A cube minus of A square equal to 0, right? So minus A cube minus 2A cube हुआ total. A square 3 times minus 3A square plus 1 equal to 0. What should be the greatest value of A now to satisfy this? Right, minus 2A cube, correct? 1 2 3 minus 3A square, इसको यहाँ लिख लेते हैं. Minus, if I separate 2A cube plus 3A square minus 1 is equal to 0. Right, 2A cube plus 3A square minus 1 equal to the 0. Okay, so can we factorize this? Can we try and factorize this? देखो थोड़ा सा try करते हैं. So I have 2A cube plus 2A square plus A square minus 1. ये minus में जा रहा है. That is I think the problem ना. 1 into 1 minus A square minus of minus 1. Then you have minus A square, perfect. Minus of A square minus plus है. तो 1 minus A square, तो minus A square minus A cube minus A square equal to 0. So minus 2A cube minus 3A square plus 1 equal to 0. Perfect up to this point, and this is equal to 0. Right. So if I take 2A square outside, I have A plus 1 plus, this is factorized as A plus 1, A minus 1 equal to 0. Right. इन दोनों को club किया, club these two. Right. Then I have A plus 1 common. Then I have 2A square plus A minus 1 equal to 0. So A is minus 1, that is one of the solution. From here you will get, it's a quadratic roots, right? It's a quadratic root, and for quadratic root you have minus 1 plus minus root over B square, that is 1 minus 4AC, so that will become plus 8. A is divided by 2 into 2. So what are the values of A coming up? A is minus 1, then minus 1 plus minus under root of 9, that is 3, and then divided by 4. So A is eventually minus 1, minus 4 by 4 is again minus 1, and then you have 3 minus 1, 2 by 4, that is 1 by 2. What is the greatest value of A? Modulus of A bhi nahi pucha hai. What is the greatest value of A? 1 by 2. What is the greatest value of A? Guys, check out the calculation. 0.5 it should be. 0.5. Yes, Setupati AKG, correct answer. Right, 1 by 2. All okay? I think some of you are commenting minus 1 or some other thing. Please check it up. 1 by 2 should be the answer. Correct answer is 0.5. The correct answer is 0.5. Right, everybody? The correct answer is 0.5. Okay, non-trivial solution. Next question, number 24. Guys, again, this is very simple, trivial solution. So one more homework. All similar questions you can try as homework, because only calculation part is what we are discussing here in the similar question. Trivial solution. So mod A not equal to 0. That is why options are in the form of not equal to. Options not equal to form में होना चाहिए. Actually both non-zero आएगा, both not equal to आएगा, right? ठीक है. Yeah, we'll plan some basic sessions also of linear algebra. But Hanumanth, this can also help you. If you follow this session from starting, this can help you. But yeah, this is not from the basic, this is from the questions reverse methodology. First we take questions and we discuss the properties and the related concepts. So this is next homework for you guys. This is the next homework for you. This is the next homework for you. Right. Acha. अब एक चीज देखो. Normally, let us go back to ax equal to b. Right. Right. Normally, we have ax equal to b. Let's go back to the non-homogeneous system of equations only. Right. Non-homogeneous system of equations. Right. Let's suppose n is the number of variables. Let's suppose n is the number of variables. Then guys, what is the size of A? Then A is a square matrix of size n cross n. Then A is the square matrix of size n cross n. Okay. That is known as n variable n equations. That is known as the case of n variables and n equations. But suppose you have n variables, right, and 2 equations only. Such a system is said to be underdetermined system. Underdetermined system. You are given 3 variables, right? You have n variables and 2 equations. Let me write down. And less than n equations. Let's say m. 2 equations and थोड़ा और जनरलाइज करते हैं. Suppose you have n variables. इसको भी erase करते हैं. Then I'll generalize this in a single shot. You have n variables, okay, but you have m equations and the number of equations are less than the number of variables. Such a system will be underdetermined. Such a system will be underdetermined, right? And if m is greater than n, such a system, when more number of equations are given, such a system is said to be overdetermined system. When more number of equations as required, right? The size of the matrix, see how many rows are there in the matrix depending on the number of equations, right? How many columns depending on the number of variables. As an example, I will explain you, right? As an example, I'll explain you. How many rows in the matrix? First equation, second equation, third equation converts to the first row, second row, third row. So how many equations? M equations, so M rows. How many variables? You need in every row, you need how many numbers? You need the coefficient of every variable. How many variable? N variables. So this is M cross N. Achha, have a look into this example first. इस example को देखिए, right? This is x plus 2y plus 2z is b1, 5x plus y plus 3z equal to b2. So this is 3 variable case. Right, but this is only given 2 equations. This is known as underdetermined. This is known as underdetermined. This is known as what? This is known as underdetermined type of system. This is known as underdetermined type of system. What should be A? A will be M cross N, right? That means A will be a 2 cross 3 matrix. That will be A will be a 2 cross 3 matrix. How A is the 2 cross 3 matrix? Let us understand in this next slide. Okay, so you have x plus 2y plus 3z is equal to b1, right? And then you have 5x plus y plus 3z is equal to b2. Ye given hai, right? How do you write down this system in the matrix form? You will have 1, 2, 3, 5, 1, 3 multiplied by x, y, z. The variables are still 3. Is equal to b1, b2, right? So what is the size of this matrix? Ye dekho na, this is 2 cross 3. Automatically this is 2 cross 3. Only 2 rows to fill up, but number of entries in each row, number of columns, x ka coefficient, then y coefficient, then z coefficient. So how many columns? Number of variables. How many rows? Number of equations given. So that is m cross n. That is why in general I have written this as m cross n, and this is an underdetermined system. It is 2z. It is 2z. Oh sorry, ठीक है. I'll just make the correction. There was a reading error. I'll write this as 2z. Here also 2. But even if it is underdetermined or overdetermined, the method remains the same. Guys, even if it is underdetermined or overdetermined, for both, right? For both, Rauch's theorem, that flow chart you have discussed, na? Right. That flow chart that I told you, that Rauch's theorem, it is still applicable as it is. There is not going to be any change in the method. There is not going to be any change in the method. So what is that Rauch's theorem? What is that Rauch's theorem? Pick kar lete hai na? Right. What is the A and what is the A is to B? What is the A is to B matrix? Combined matrix likh dete hain. So 1, 2, 2 is to B1. 5, 1, 3 is to the B2. 5, 1, 3 is to the B2. ठीक है, ध्यान देना. Okay. Now pick up any one minor. 1, 2, 5, 1. Pick up any one minor from here. Right. Calculate the value. 1 minus 10. This is not equal to 0. That means you have a 2 cross 2 minor non-zero. You have a 2 cross 2 minor non-zero. What is the total size of A is to be? 2 cross 4. What should be the maximum possible rank? 2. What is the maximum rank? Minimum of Mn. Remember, minimum of Mn, right? Minimum of Mn, right? So there is a 2 cross 2 matrix not equal to 0. There is a 2 cross 2 minor not equal to 0. So rank will be 2. Now this is a minor of A. This is a minor of A is to B also. The same minor, it is a part of A also. It is a part of A is to B also. So if I have found one non-zero minor which is common to both A and B, so I can say that rank of A and rank of A is to B both is equal to 2. No need to convert to Echelon form. Directly I am able to feel. Na? If you want, you can convert to Echelon form, but directly I am able to feel. So both the ranks are equal and equal to number of variables. Is it equal to number of variables? No. Both the ranks are equal to 2, less than the number of variables. This is less than 3. Both the ranks are equal but less than 3. So how many solutions you will have? Both the ranks are equal, less than number of variables. So infinite solutions. Infinite solutions. Right? The system will have infinitely many solutions. The system will have infinitely many solutions. ठीक है? Unique solution तो हो ही नहीं सकता. That means यहाँ पे it can be either infinite or no solution. For underdetermined, you can't find the unique solution. For underdetermined, it clearly means you can't find the unique solution. Na? You can't find unique solution because rank of A is to B is always equal to minimum of Mn and M is less than N. Underdetermined का मतलब ही ये है M less than N. Underdetermined M less than N. Right? So what is the minimum of Mn? It is M. So rank of A is to B, even if it is equal, it can be maximum M. It can never touch N. And if it can never touch N, it cannot have unique solution. No possible. That depends on the jumbling of the numbers. That still may be possible, but unique solution never possible. Right? So for underdetermined, unique solution not possible. For underdetermined, unique solution not possible. For underdetermined, unique solution not possible. Right? Chalo. Okay, so this was the question number 25 for the day. And guys, now tomorrow at the same time of 11 a.m., all dear students, tomorrow at the same time of 11 a.m., tomorrow, the very same time of 11 a.m., we are all going to connect once again and discuss the part number 2, right? That means question number 26 to question number 51. All 51 questions I will have promised 51. I will give 51 questions. But the very and the most important topic you can say of linear algebra, eigenvalues and eigenvectors, just like today, it is not only questions. It is not only questions, but if you have attended the today's complete session, you might have felt that we are discussing the concepts, the properties, no detailed theory, no derivation, but we are discussing the techniques, the formulas, the revision, important points and the concepts along with the question. So it is going to be similar tomorrow. Please do mention in the comment box, right? Yeah, Kylie Hamilton will also come up tomorrow with eigenvalues only, right? PDF password is given in the mid of the session, right? So guys, PDF password is there in the mid of the session. So guys, please do mention in the comment box how much you enjoyed the session, right? If you feel that you have enjoyed, I will plan some more on the weekends. I'll plan some more sessions on the upcoming weekends. Don't worry regarding to it, okay? Okay? So tomorrow 26 to 51 question, eigenvalue, eigenvector, tomorrow at 11 a.m. and tomorrow you have one more session, right, for all the GATE 23 aspirants. Tomorrow 8 p.m. Also join me tonight, same BYJU'S Exam Prep YouTube English channel. Do not forget to subscribe. In case you are not subscribed to the channel, do subscribe so that you get notified. You are updated about all activities of the session. So tomorrow, GATE 23. Last 3 months, last 100 days left. What are the frequent doubts in any aspirant's mind? Right? How many number of hours now? From where to practice? What is the right time to begin test series? Where is the revision plan? Right? And is 75 plus still possible? Let's get an answer to all of this tomorrow 8 p.m. same channel. Keep subscribed to the channel. Hit the subscribe button if you have not subscribed. Okay. And let's connect tomorrow 11 a.m. Yes, tomorrow 11. Bye bye. See you tomorrow, and do not forget to download the BYJU'S Exam Prep app also. There also sessions are running on. Okay, bye-bye. See you tomorrow. PDF will be shared in the Telegram group. PDF will be shared in the Telegram. I'll share you the Telegram right now. I'll just share you the Telegram right now. Just a moment. Just hold on for a moment so that I can share you the... Bye-bye. Yes, guys. Here is the link of Telegram also. Okay. Those who wanted Telegram is there. Link is there, guys. I am not visible, but link मैंने share कर दिया है.